I'm Graham Lau, also known online as the Cosmobiologist. I'm an astrobiologist and communicator of science, and a longtime fan of the now gone Arecibo telescope. For me, growing up, I think I first came to knowledge of Arecibo because of the film Contact that starred Jodie Foster, playing a part that was very much based on the real living person named Jill Tarter, a scientist from SETI. Carl Sagan, when he wrote the novel for Contact, had based much of the character on her. And I had the honor of interviewing Jill some time back for my show for NASA called Ask an Astrobiologist. In my career field now, I've pursued biology and chemistry and astrophysics and eventually earned a PhD in geology. And then I spent a lot of time learning about communicating science and how we share our endeavors in astrobiology and trying to understand the nature of life with everyone else. And Arecibo was a very large part of that for a lot of us. Arecibo was used to look for signs of life out there, to look for radio messages, for instance, from potential extraterrestrial intelligences that could be out there. We even sent one of the messages from us out into space called the Arecibo message, which was constructed by Frank Drake with the support of many other people in the astrobiology realm to show that we had the ability to send messages out there. Of course, in the time since then, we've now had a much larger conversation about who gets to speak for Earth and should we be sending messages out there. But large telescopes like Arecibo are super important for us, not just in astrobiology, but also for understanding the history of water on the moon, for looking at other worlds in our solar system, for looking at other stars, for understanding how the universe is functioning, and in seeing in radio waves what's going on in our neighborhood, in the galaxy, and beyond. And I have to say that the collapse of Arecibo was saddening for many of us. But I think it also maybe could be a point of hope in that we can rebuild. We can build more large telescopes. We can build more of these great observatories, gravitational wave observatories, things like the Large Hadron Collider, these large particle accelerators, very large telescope interferometers where we have a lot of smaller telescopes linked together in a larger telescope. And then, of course, large telescopes like Arecibo was, or like the newer FAST telescope in China. We can make these very large observatories, ways for us to understand the nature of the universe around us. All these different ways for us to increase our perception. You know, besides our senses of sight and hearing and smell, we can also use these kinds of instruments like Arecibo to peer into the universe around us and know more about who and what we are.
My name is Pia Salter-Ghosh, and I'm the daughter of two astronomers who worked at the Arecibo Observatory from around 1992 to around the end of 2017. I wasn't literally born there, but days after my birth, my mother had a crib in her office, and she had me in there. People kept coming in and disturbing her work, apparently, to say hello. And that was just a constant my whole life. Every time I would go up there, it wasn't like I was going to my parents' workplace. It wasn't like I was going to visit the largest radio telescope in the world. It was just coming home to me. So one thing with Arecibo is very few of the staff scientists, in fact, I think none at the moment, actually live on site. We all generally live nearby, like within a 20-minute commute. However, the amount of time we spend up there, we might as well be living there. So basically that would have been from when I was born until I was 18, and I left the island to come here to study, come here to the UK to study. Oh my goodness, it was wonderful. I absolutely loved being there. I don't even have to close my eyes to think about it and feel like I'm there. It's the sort of place, it's like the biggest, most beautiful playground when you're a kid. And especially if your parents are like mine and assume that you're not going to do something ridiculous and, you know, stick your hands in some equipment or something. it's a pretty safe place actually for kids to run around in. There's a swimming pool with a volleyball court next to it. I spent a lot of time there, as you can imagine. But also, the observatory is built into these massive karst hills, into the sinkhole. And there's a whole lush tropical rainforest all around it. And in addition, bits of that whole area have been, of course, groomed so that people can get to different parts of it more easily. So one thing me and my friends used to do quite often is there was this walkway from the office building, which was sort of in a dip between two of the hills around the dish. From the office building, you could go up through the stone walkway that was cut into the limestone and up these wooden stairs to where there were these old wooden cabins where often visiting scientists would stay. And that whole area, you know, even as a child, even when I saw it pretty much every day, it was like something out of a fairy tale. It's just this beautiful like green tunnel, and you look up and it's like a stained glass window overhead almost. That's one thing I think people don't talk about enough, is just how beautiful and evocative in many ways the site is, more than just the dish, the whole place. There's so many little secret places that you wouldn't really know unless you were a child who, you know, your parents had shooed you out of their office because they were trying to have a meeting and you were being loud. And you just end up finding the strangest places. I found one of the seismographs at the telescope completely by accident once while climbing a hill. Like, tripped over it when, what's this strange block of cement? Spent a while spelling it out. I was quite young at the time. Ran into my mom's office like an hour later going, "Mom, what's a seismograph?" So one of the great things about the observatory is what a massively diverse community it gathered around it. Now, in terms of friendships, it's an interesting one, because when you live at a place like that and you're part of, well, you're related to the staff there, there are, of course, a lot of transient friendships. So there were many astronomers who came for like a year, 6 months, and they'd bring their kids, and I'd have a new best friend and I'd be super excited. Finally, there was a kid who was my age. And then, of course, in a year, they'd be gone. Unfortunately, I was the only person my age, but there was a boy who was 3 years older, who was a bit of an older brother figure. And there were these two girls who were 3 years younger than me. Their names are Gayatri and Rhiannon. We are still really close. They're basically my sisters, and Rhiannon's little brothers are basically my brothers. It's this extremely tight, unique bond. And I really do think I'm an only child, but I think it must be quite a lot like having siblings because of the amount of time you spend together, you know? You have enough time together to get absolutely sick of each other, for different groups of you to gang up on each other, and of course, to love each other very much. Pretty much all the people who were there while I was growing up, the staff astronomers, they were like my uncles and aunts. Like, they're more my family than my biological family are in many ways, you know? It really is a family. Well, I think being around such a large group of intelligent and interesting and actually like creative people has, you know, really given me a sort of a goal. Like, I want to be the kind of person that I would have thought was awesome as a kid. And most of those people were scientists, were engineers, were, you know, people who worked on the platform crew. No one talks about them enough. Most of them are locals, and they worked so hard, so many years, even generations of people working on this site. And everyone brings something different to the mix. And then, of course, there's a whole group of people who aren't necessarily working at the observatory, but who come with the people who are working at the observatory. And they're interesting too. We've had writers, we've had artists, we've had all kinds of different academics. And, you know, there were even a couple of movies filmed there. over the course of, you know, my childhood and the time my parents were there. Really, you could pretty much meet almost any kind of person there at some point. I believe it did, but not necessarily in a way where I'd say, oh, well, look at me, I'm a radio astronomer now. It was more just everyone there was extremely, extremely supportive of any intellectual pursuits that I had. So I ended up coming to the UK to study. Initially, it was classics at the University of Cambridge. I ended up switching to archaeology because classics was not sciencey enough. One might ask, why not actual sciences? Even I don't have a real answer to that question. I suppose there was a teenage desire of, I'm going to do my thing. But I still constantly tell myself, I'm totally the kind of person who at 50 might end up going and doing a random PhD in astronomy. Wouldn't be out of character. As for what I'm doing right now, I, of course, did get my undergraduate degree. I did quite well at it, but I actually do not work in archaeology and never really did. I'm currently working on a master's degree in creative writing. It should have been done by now, but it was pushed back by the pandemic. Absolutely. I think it would be impossible for that not to happen, It's a mixture of how kind the people are, how interested they are. It's so easy to brush off like the random children of some other scientists, but people there were always very kind to me, very interested. Years later, when I could not remember them, and I'd run into them at various astronomy conferences my parents would take me to, people would recognize me and I'd have no idea who they were. So, I knew you when you were this high. Thanks. Yeah, so the thing with the collapse is, of course, in the eyes of the world, it's like this single shocking event. But from my point of view, as someone who spent a large portion of my life there, and after that, of course, constantly hear about it from my parents, it was very much a death that was well announced. It was a death that we saw coming, that the first diagnosis, if you like, came around 2006 when the senior review from the National Science Foundation was carried out of the observatory. There were times when it got better, there were times when it got worse. If we think of it like a disease, the course of a complicated disease that ebbs and flows, and you never exactly know when it's going to hit bad enough for it to be the end. It was very much that sort of situation. I remember when Hurricane Maria hit in 2017, my first concern was, are my parents all right? I didn't hear from my parents for I think it was a couple of weeks. It was incredibly traumatic sitting here not knowing whether they were alive or dead. But the other thought was always, is the observatory still standing? And it's strange because when I was a small child, it was hit by a stronger hurricane, I believe. Not entirely sure. And there was no real concern then because there was the money to basically ensure that nothing was going to happen to it. But the last 20-something years have been a bit of a question mark. Like you never quite know when something's going to be the tipping point. It did not need to be this way. There were many things behind it being this way. And there's no real one person you can point to other than saying there's a lot of complicated human elements that led to this situation. I guess what I'll say is that telescope, if it had been maintained the way that it was in the 90s, had a good 20 years left in it, possibly more. But this is how it is. I suppose my initial reaction was, I can't believe I'm actually surprised about this. I shouldn't be surprised. We all knew this was coming. But you can't help but be surprised when something that you love so much, something that, yeah, it's like a family member, like the grand matriarch or patriarch of the family, I suppose, finally goes. And you're just sort of left to apportion out the inheritance and the blame in equal parts and just work out what's going to happen. I think everything's happened so fast that I haven't had that much time to even really grieve and process how I feel about things, which is why I might seem a bit unemotional here at times. But it feels like a very urgent situation. It's been very rough. I've been crying a lot and haven't had the time to think about why exactly I'm crying, what exactly I'm crying for. Is it for me? Is it for the people I know who work there? Is it for the telescope itself? Is it for Puerto Rico? I don't know. And it's going to be something I'll think about for a very long time. Yeah. I think inevitable is really not the right word. I think it absolutely could have been avoided, especially if there had been swifter action when the first cable broke back in August. At that point, there were many options. There were engineers involved in mega construction saying, this can be done. Why is no one doing it? I know the NSF carried out their surveys. Obviously, I'm in no way qualified to say if they were right or wrong. But a lot of people think that there may have been more that could have been done. As for the last 20 years, I really don't know how much is exactly appropriate to speak about. I will say that a lot of this stuff can be found on like various observatory related web pages. The senior review that I mentioned from 2006, for example, is one that can be found pretty easily on some user pages on the observatory's website and possibly just in Google. A lot of the information is easy to find. I just feel a bit strange talking about, especially the slightly more, not in sort of big government, sort of government terms, but some of the sort of human politics behind it, especially because I know I must have a biased view of it. But I will say there were a lot of people with their own agendas who they didn't necessarily want like to hurt the observatory specifically. But when you have your project and you want your project to get done, you do prioritize that over pretty much everything else. And Arecibo suffered with that. Green Bank Radio Telescope suffered tremendously with that. It was a difficult time, and it's a time that has led to a lot of unproductivity too, because a lot of projects that were launched at that time haven't exactly come to fruition or are still in the process of being worked out. And yeah, there's a lot of messiness. So I think there's many factors of it. One is, of course, the physicality of the thing. Like, unless you've been there and looked on it, you don't really get the sense of how huge it is. In some sense, GoldenEye, which I've heard a lot of astronomers complain a lot about, was kind of great for that. You can really see how massive that structure is when you've got like James Bond hanging off it. But I think that was a big thing, how like weird and sci-fi and it looked. It was an icon of the sort of dreams that people allowed themselves to have in the 60s, something completely impractical and stupid to build, and we did it anyway. I mean, of course, it was a terrible time back then for many reasons, but this was pretty awesome. There's also the local factor. On Puerto Rico, the observatory it's incredibly iconic. Like, it's not necessarily at the tier of the cookie frogs that sing us to sleep every night, but it's pretty near that. Almost every school child on the island at some point goes on a field trip to Arecibo. Public school, private school, everyone goes. It is a huge point of pride. It's discussed in science classes. And I do believe that it is as a result of having the telescope there that you actually see a lot of Puerto Ricans involved in aerospace research. Maybe not as many end up in actual radio astronomy. Often they end up finding their interest in other places, having first developed an interest due to this. But for example, in NASA, from what I understand, there is a very, very high number of Puerto Ricans who work there. And honestly, it's been great. It's one of the few good things I'd say that we've gotten out of American colonialism. It's something we can all be proud of. It's something that many Puerto Ricans do work at. Like, there's quite a few Puerto Rican scientists now more than ever too. There's a huge crop of young Puerto Rican scientists who are incredibly involved. And it's beautiful to see. It's just absolutely beautiful to see. And then also in pretty much every other side of work at the telescope, also there have always been local people, engineers, and as I spoke earlier, platform crew and everything else, It's a point of pride for us. It's an icon. It's a historic monument. It feels like it's ours. You know, the land charter may say something different. You know, the people who are putting in the money, maybe other people. But I mean, if we could, we would. You know, I mean, that would be a dream. An observatory run by Puerto Ricans. It would just be incredible. But no, that's I think why it's iconic on the island. And also, there's of course the scientific terms. Like there's a constant stream of interesting research that comes out of Arecibo's data. I remember when my mom's team, I mean, you know, everyone she was working with, got their first detection of methanamine out there in space. I mean, it was reported all over the news as organic molecules in space. It was, you know, I remember picking up the phone one time and someone was like, I don't remember who was the name, but it was someone from Nature calling to speak to my mom. So in scientific terms, you know, there's been an incredible output. And, you know, there still will be, because there's a lot of Arecibo data that still remains to be worked on that's perfectly safe and available. Having the Arecibo Observatory running directly benefits you. There's issues of security. It's the only large radar system that can image near-Earth asteroids in that level of precise detail. If we're going to be hit by a meteor and don't want to end up like the dinosaurs, we need to be able to study the things that could do that to us. And this instrument was the most precise one that we had for doing that. Now it's gone. Now we are a lot less safe. And also, it's beautiful. It's hopeful. It provides so many jobs. It revitalizes the area around it. It provides disaster relief to the people in the local area as well. When the hurricanes hit, where do they go for food, for water? There's a helicopter pad. That means that FEMA can get in there and help people. It's a very important site for many other reasons as well, including things I haven't even managed to speak of here. It benefits you for the observatory to be open. And if you care about it, please contact Congress or your representatives, or just famous people or people involved in science that you might know to support this.
You going to start or shall I? My career started a long time before yours.
You start, then I will.
Okay.
Whichever, what you prefer.
Yeah, why don't I start and then
Sure.
you can link in.
All right.
Okay, so I go back a lot further. I grew up on the north edge of London, and then in my teenage years moved out to Hemel Hempstead, Newtown, which you'll no doubt be familiar with. Moved off to Manchester for my undergraduate days, and then being an idle sort of a so-and-so, decided I'd stay on after my bachelor's degree and do research because it saved going out and finding a real job, and did a PhD at Jodrell Bank, which belonged to Manchester University. So I stayed attached to Manchester for 8 years, and at the end of that, thought, well, this radio astronomy lark seems quite fun. I actually, at 5 years old, on being asked, what do you want to do with your life, young man, said, I want to be an astronomer all the week and play football for Watford FC on Saturdays. So sadly, I never achieved the important part of that, but I did at least become an astronomer.
You follow all Saturdays, even now?
Yeah, still a big supporter. And I, at the end of that, thought, well, do I want to try and make a career in England in astronomy? England doesn't have that many jobs in astronomy. What do I want to do? And I thought, well, if you want to find out about rats, you put them in mazes and strange environments and see what they do. If you want to find out about yourself and still keep on with the career you've chosen, you put yourself in strange environments. So why don't I do that? So for the next 20 years or so, I traveled around the world, spending a couple of years at different observatories. Let me see if I can remember where I finished up. I spent a couple of years in Italy. Then actually, at the end of that time, came back to England for 5 years, as I had a father who was basically needed someone to look after him, and came back and was a research and statistics officer at Dacorum District Council, which sounds pretty unlikely, except the Dacorum District Council is another name for Hemel Hempstead. And
Town planning, basically.
yeah, then had the good fortune of running into my old PhD supervisor, who by that time was in West Germany, as it was in those days, who said, well, we've got a position open for a postdoc in the radio telescope at Bonn. Do you fancy it? So I said, oh, sure, I'm up for that. I sadly no longer had any reason to be back in England, my father having passed on. So off I went to Germany, then went to America for the first time.
They were just building the VLA that time.
Yes, that's right, the very large array in New Mexico. And at the end of that, I was talking to a visitor from India who said, well, what do you think of America? So I said, well, I'll be honest, I think it's somewhat uncivilized me. And he said, why don't you come to India? We'll re-civilize you. So I thought, well, that sounds good. So off I went to India for a couple of years. And at the end of my time there, met a new PhD student who was starting there called Tapasi Ghosh, who basically we said hello. And I got told to tell her about radio astronomy. And as she put it many years later, you were really pompous. And off I went, then spent another 2 years in the USA, finding it could be more civilized by living in Tucson. And but that wasn't the end of it. Back to Spain for a couple of years. At the end of that, I didn't think I'd finished with India. Back to India for another 2 years. And at that point, the aforementioned Tapasi Ghosh was finishing her PhD thesis. We finished up getting to know each other an awful lot better. And at the end of my couple of years there that time, I realized there was someone I didn't particularly want to leave behind in India, except at that point, she was off for a postdoc in the Netherlands. So I went for my third time to the USA, to Greenbank in West Virginia, which features again a bit later in both our stories. And we, at the second time of asking, decided to get our lives together. So we got married in Tucson, West Virginia in 1991. And then the problem was she was in Netherlands being a postdoc. I was in actually in West Virginia. And that was a long way between each other. So we looked for jobs together and found a job going, or two jobs going, in Puerto Rico at the Arecibo telescope, which we all knew of. Arecibo was built, in fact, in 1957. In
63, opened
in 63. It was planned in 57. And just about the time I started in radio astronomy. In fact, I was told at Jodrell, hurry up and get your own thesis done. There's this new telescope in Puerto Rico, going to kill us all stone dead, which of course it never quite did. But I knew about it from the earliest days. And I thought, wouldn't that be wonderful to go and work in Puerto Rico at that fantastic great telescope?
And they were just doing the Gregorian upgrade, the big dome that you see.
Just planning
that
it.
was just beginning to happen that time. So
Yep.
It was challenging time.
So we applied for the two jobs there, not dreaming we'd get them. And to our amazement, we got offered them. At the same time, this girl got offered a job at Greenbank. So we had to decide where we were going to get our lives together. I went over to Holland. We spent 2 marvelous weeks in which we didn't talk about where we were going to live. And at the end of it, we thought, well, we've got to make a decision. So we sealed our preference into 2 envelopes, exchanged envelopes, opened them, and thank God both of them said Puerto Rico. So there we finished up in Puerto Rico. And for the next 26 years, marvelous years, of which our daughter, who you met this morning, was born, raised, rebelled, did everything young
Kids
daughters do. And at the end of that, having decided that she was an Anglo-Indian who was really, as she once put it, 50% English, 50% Indian, 100% Puerto Rican, she went off and studied in the UK, and I'm sure you've heard the rest of her story. And in 2017, we survived Hurricane Maria, which was an experience, category 4-5 hurricane that went through and
destroyed a lot of
the island. The telescope survived that one, although it did get damaged. Everything, I think, got damaged. But after 6 months beyond that, Tapasi had the offer of a position at Greenbank, of all places. I decided at 75 years of age, it was time to retire and give somebody else a slot, or maybe 2 people slots to move into. So I took retirement, and Tapasi decided, well, this is a new challenge. For a couple of years, until she came up to retirement age, we'd come to Greenbank, and then we still have our house in Puerto Rico, and our plans are still to move back to Puerto Rico when the pandemic gives over. She will decide on retirement when she decides, and we will move back and carry on our life in Arecibo. We still have an awful lot of Arecibo data we haven't analyzed, and we'll carry on. I'm in theory a Emeritus staff member at Arecibo, and we'll carry on hopefully being Puerto Rican residents and scientists at whatever Arecibo Observatory looks like a year or 2 down the road. Now you carry on with your story, whatever I've left of it.
Well, you talked much about my working life, and before that, I'm born and brought up in Calcutta, India. And then after I did my master's in physics, I chose to do research at Indian Institute of Science in Bangalore. So that's where I went. And at that time, they were doing a joint astronomy program involving 5 big institutes in India, including Tata Institute of Fundamental Research. They had their radio telescope at that time in a place called Uti, up in the southern mountains. Now they have a big interferometer called GMRT, Giant Meter Wave Radio Telescope. You might have heard about that. But when I was a student, ORT, the OT radio telescope, was the main telescope. That's where Chris went to visit as well. So anyway, so that's, I was doing my PhD there. And when I went to do my postdoc in Holland, my idea was to go back home because the GMRT was coming up, and my original plan was to go back and maybe take this guy along with me over in the other direction. But life turned out completely different, unexpected, and wonderful in some ways. So there we are.
When you've got a daughter who decides she's Puerto Rican, it's very hard to up sticks and move again.
No. Now, of course, we spend so much I entirely worked outside within the U.S. system, so I wouldn't even know how to function back in India. So that's out of the question. And my parents are no more as well, so there's no incentive of going back there at the moment.
It was never uncomfortable. Everywhere I lived, I enjoyed myself. It was fun. And everywhere I lived, I found that the vast majority of people were very pleasant, very nice. And I could have happily if everyone said, right, all your return tickets or tickets to anywhere else were torn up, then I could have happily lived there. Traditionally, I was our galaxy person. My own thesis work was essentially mapping the
Whole sky.
the radio, well, the whole sky, but in particularly concentrating on the radiation from our own Milky Way galaxy. And that carried on really through my next couple of places I went to. And it later branched out to taking an interest in galaxies beyond our own galaxy, and even inwards, in that when I was in Spain, I even got involved in the first radio detections of the planet Pluto. So I always call myself jack of all trades and most certainly master of none. So
You're too modest.
Yeah. And
but you were the head of radio astronomy.
Yeah.
When we went to Arecibo, Chris was the head of astronomy group there, so he had the charge of a lot of other things as well, just not just his own research, but the whole group, plus representing the astronomy community's desire as to what instruments go on the telescope and how the time gets divided and various other things.
That went on from 1992 to 2004.
Yeah.
And at that point, that took the majority of my time. And I realized that bureaucracy wasn't really what I enjoyed. What I enjoyed was the research side of astronomy. So I said, right, now's the time to pass it on to somebody else who might enjoy it more, or certainly is younger and more vigorous at such things, and I'll go back to worrying more about what's going on up in the sky.
Talk about Galpax.
Yes, in fact, I came back to my original interest then. A new radio camera came to Arecibo in 2010-ish, which instead of looking at just one place in the sky, as we had done at Arecibo before, looked simultaneously at 7 places in the sky. So you effectively had a simple 7-pixel camera. And we decided one of the things we could do was to map the foreground emission of our galaxy. And so back to where I was in 1965 at Jodrell Bank, mapping the northern hemisphere emission of our own galaxy. And that was great fun. It made certainly a large amount of closure. Of course, I say me, there was something like a consortium of 30 or 40 astronomers, including the person next to me, involved in that project. So, and that's all coming nicely to fruition now, maps of the emission of the whole sky, because the sky is not dark at night if you had radio eyes. The sky is bright at night. It's lit up by the emission of cosmic ray electrons spiraling around between the stars in our galaxy, around the magnetic field of our galaxy. It would be, you wouldn't have a dark sky. You would have a light sky to your radio eyes. And that is what has always captivated me radio-wise, is mapping that bright sky. And I went away. This lady corrupted me into being interested in galaxies outside my own, or outside our own. And maybe you want to say a little of what you're interested in.
Is that you finished? No,
well, I could find lots of other things, but I'm sure I'd be much more boring. So you
No. You haven't finished yet. Talk about R220 and NGC660.
Oh yes, well, really, you're again involved.
Well,
in
I'm
that.
involved in some of those, but talk about methanamine.
Yeah, one thing at Arecibo, after I'd stopped being head of astronomy, I noticed we had 8 or 9 astronomers in the radio astronomy group. But one thing we did was our own thing. None of us had really combined together to do one piece of work together. So we talked around our tea time every afternoon. We had a good number of Commonwealth and British astronomers. We used to get together for tea every afternoon. And we thought, yes, it would be nice if we all decided to do something together. And one thing we thought would be nice, we had a telescope after the 1990s that would cover a very large range of frequencies. And we had the possibility of breaking the whole of the frequency band down into small frequency chunks, frequency spectra, as we call it, and looking for spectral lines of different, you'd know this as a scientist, different spectral lines of different molecules and atoms, and seeing what an object was made up of chemically. So we decided on picking a galaxy, ARC 220, which has very high star formation, and scanning it across the whole range of frequencies available to Arecibo, and seeing what we saw. And that turned out to be very productive. The first night we started the project, there were all 9 of us in the control room. Typical, the men said, we're going to drive. So we went and sat in front of the control desk and pointed the telescope, followed the galaxy, decided what band of frequency we were going to do. The girls...
Only two.
You and Barbara and Myra.
Myra, 3.
Yeah, good Puerto Rican astronomer, Myra Lebron. They went and sat at the computers and looked at the data, the much more exciting part, really, as it came off. So the men all sat there and said, right, we're pointing at it. We've clicked, take data. Do you see anything? And from behind us, we heard, there probably is a molecule there. It's something called methanamine. And we said, really?
What is
Come
that?
on, what's that? It's probably a interference from some terrestrial source. What is methanamine? And a voice came and said it's...
Well, I didn't know offhand, of course, but we looked it up, and it is actually a prebiotic molecule. So we'll talk a little more about that.
Chemical was...
Yeah, it's a CH2NH. It's a very simple chemical formula, CH2NH, but it is actually considered prebiotic because methanamine plus hydrogen cyanide, HCN, combined together with water through a process called hydrolysis, apparently, can make glycine, which is one of the fundamental amino acids, the 20 amino acids that make up all the proteins. So when we saw that, there is a catalog basically that has this transition belongs to that molecule, and then you read up on that molecule, what it could do and what has it been found before. So we were doing all of that, and we found that this is a prebiotic molecule, and finding glycine in an astronomical object has been the holy grail of astronomy for some time. People have claimed that there is, they have detected, but it hadn't been confirmed properly. 20 years, in 1970s, methanamine was detected from towards our galactic center, Milky Way. But this is external galaxy, 77 megaparsec away.
So
can't do it.
About 220 million
light years away. So, and this is an environment where two galaxies are actually colliding. They're hitting each other and just sort of in a big collisional system. So they are going through a rapid star formation. Their star formation rate is 100 times faster than Milky Way. So it is a very violent kind of environment, and we see this molecule there. So we were very thrilled. And that night, of course, we just
should
knew
make it clear.
Only this molecule is there. And as we started reading up more, we got more and more excited. So,
we should make it clear we haven't detected glycine. We detected
a part
the
of
bricks
glycine
that make the wall that make glycine.
Exactly. And HCN was also seen at infrared frequencies for their other transitions, but we saw in our data, special transition of HCN as well. So all these were very, very, very thrilling. People have detected water in up to 20 as well. So all these little pieces are there. They haven't detected glycine yet. So it was something new. And on the first observation, we hit this and we were
And
very
all we
excited.
men did was drive the bus.
No, come on. And then we had 20 more galaxies of sort of similar characteristics otherwise. Out of those, 3 more showed the same chemical.
Yeah.
So it's not just one freak chance. So these kind of objects are showing that molecule. They do contain this molecule there, which was really exciting.
Actually, our latest interest has been looking for scintillations of radio sources seen through the tails of comets. So we've been doing that with an Indian friend of ours who's now on the staff at Arecibo. And we were just beginning quite a large program between Arecibo and Green Bank, where we now are, and observing with both of the telescopes. You know how if somebody carries a candle in front of a frosted glass window or a torch, it appears to twinkle and scintillate. Well, if you have a radio source and a comet's tail, which is its ionized tail, passes in front of a steady radio source, the radio source can appear to twinkle. And that tells you an awful lot about the distribution of the ions in the electrons in the comet's tail. And we had just begun that program, sadly, when Arecibo took a dive. We will carry on doing what we can do with Green Bank, but of course, it's a much smaller telescope, and we'll be doing it for brighter comets.
Also, pressure on Green Bank is going to increase. A lot of Arecibo users will now try to use Green Bank. They'll need a little more time. Some of the observation cannot be done here, but the proposal pressure is going to go up here.
It'll be harder to get time on Green Bank.
Yeah.
So it's a knock-on effect.
Well, it was amazing. It's very difficult to summarize everything. You know, for me, I mean, we both of us, even though we're family, all of us will have our own perspective, you know, including Pia. She was born and brought up there, but we all will have our own perspective. For me, it was like once I was not close to my parents, it didn't matter where I was as long as I was doing work that I loved. That was my attitude to go to Puerto Rico, that if I couldn't be within just stopping distance of my parents, it did not matter how far I was. Of course, it mattered, like you couldn't go take a bus ride or taxi there. So it didn't matter. But in principle, the science that I wanted to do took me there. And 2 jobs in one place in astronomy took me there. But once I was there, I found people of Puerto Rico were very accepting. They were just, not a single day I got any question saying that, where are you from? I mean, they did ask, where are you from? But it was a friendly question just to know where I was from. It didn't have the connotation like you don't belong here, right? I didn't feel any hostility there, which I feared a little bit, because when you go to a different country to live, you always wonder how well you will blend with the people there. That was never the case for me. And maybe because as an appearance-wise, I didn't stand out very much, because Puerto Rican people they have the diverse look. They have 3 different gene strains there, and people look very diverse there, much more than any American cities. Like here in West Virginia, I stand out anywhere. But West Virginian people are also very sweet. I'm not pointing out anything. But the thing is, people there were very open, and they'll come, give you a hug, kiss you on both cheeks, whether you're ready or not. They'll just hug you, and they'll just fold you into their families. So that happened with our first landlord. Then all our staff, kitchen, the lady who worked in the cafeteria, kind of adopted me, because very soon I became pregnant with Pia. She sort of adopted me. The secretary considered me as her sister. She would give me all kinds of advice, what to eat, what not to eat. I didn't really I miss my parents, but we had a new family there. The 100 people at the observatory were my family. Yep. And they were the uncles and aunties of Pia that she did not have close by. So we had a home there, we had a house, we went back, but observatory was really our home, because we were there over the weekend and we were observing at night, day, anytime. Pia slept in my office as a little baby. Then later on, day and night, whenever we go to observe, she will sit in a corner in the control room in a sleeping bag. So our friends were all there. Local community we began to mix with when she was bigger and going to school. So I joined Girl Scout movement with her, taking her there. That was a wonderful exposure to the community for me. I did not learn Spanish, even though I tried. I did not learn as well as I wanted to be able to read and write.
And I lived in Spain.
No, I mean, your bookish knowledge is much better. I gathered it from people, so I could communicate it a little bit better. But everywhere, I never felt I was not accepted. Only trouble probably was we were not part of a church, because religion is a huge deal in Puerto Rico. Many people are very religious. They go to some church or the other, and many of their social activities happen with the church. Now, we're not practicing religious people. Whatever belief we have or don't have, we keep it within us. We don't really participate in any organized religion. So we did not do that. But a lot of activity happens that way. And that section of the society we missed completely connecting to. But other than that, we had a pretty good life, I would say. And I don't know. I mean, negative things were always there, of course. Sometimes power won't come. And coming from India, I was used to it. I grew up with the time when 4, 6, 7 hours we did not have power. I had to study with candlelight and things like that. We had something called load shedding. So those things didn't bother us. It bothered many people at the observatory, our other colleagues. They'll say, oh, we don't have power. But it didn't bother me that much, because I was used to not having power for some time.
Again, it was another viewpoint for me on the world, another maze to run around in. I found the people very, very friendly, very, very accepting, as Tapasi said. Absolutely, we miss many, many people. We still, through Facebook particularly, keep in contact with a lot of people. I wish my Spanish had been better. Unfortunately, keeping up with one's science and, what should we say, learning the language, particularly, I was, I guess, 50 when we moved there. In fact, exactly 50, I think.
No, a bit before.
No, not much. 92.
Oh, yeah.
50. It's much more difficult. For instance, I considered myself at the end of my 2 years in Italy completely fluent in Italian. I found I was thinking in Italian, dreaming in Italian. I would give lessons at the university there in Italian. And I think Italian is the easiest of European languages. So I was lucky I picked the right one there. When I moved to Germany 5 years later, I found out I was not a genius at languages. German,
but you still learned German.
I learned German badly. I learned Spanish badly. But I started at much later in the day.
You learned 2 South Indian languages.
Badly,
Even to write.
very badly.
Not one of mine, but he learned his 2 other Indian languages.
One thing I must say is I was so impressed that the average Puerto Rican's grasp of the world, that they have an understanding of world politics, of world, what should we call it?
Geography to start with.
Geography and history that is very much better than the average US American. That Tapasi said people would find out she was from India and she would be quite surprised they would know a fair amount about Indian background, history, where it was in the world. Whereas I, a number of times, would get asked at different places in the US, oh, you're from England. Do they speak English over there? And I don't know if you ever had that experience, but I would say, oh, yes, they do, yes. And then walk away shaking my head. It was, I never got asked that in Puerto Rico.
No, in US, just by my infrequent visits and now 3 years living in West Virginia, is that there's almost like a 2 population. You know, if you deal with cities, towns, and bigger places, and then you go to rural places, they're just 2 different countries. As the divide is so deep, I don't know how and if ever there will be a bridging.
Yes. It's a very difficult question to answer, maybe because it's so different to every other radio telescope. Every other radio telescope looks the same. It's a dish, it's a parabola, it's a classic thing that Gary Larson draws in his cartoons.
Or people are familiar with their TV antennas for some time.
Yeah.
Now antennas have become smaller, but people have seen dish antennas.
Maybe to the Arecibo message that captured a lot of people's imagination. The idea of sending a message out into space.
But that hanging platform, and once you're there at the deck, the observing deck up at in front of the visitor center, that immensity of that huge thing really hits you. It's like, it's nothing like in the picture. You know, even some days when I would feel down for some other reason, I'll just go to the deck and stand. And if you stand there, you just get sorry, I'm getting emotional, but that view itself was just amazing. I mean, there was all the karst hill you see, the nature around you, and then this amazing structure right in front of you, standing there. It was just very emotionally emotive, I should say. Even if you didn't work there, if you just went and stood there, the emotional impact was a lot. And whoever visited there, they just can't forget that impression, I think.
Yeah, I think, not speaking for other people, but for us, it really was like a member of the family. We spent...
that was our place where we were. But
hundreds of nights up there. We would, you know, it was quite normal to get up at 2 a.m. We lived in Arecibo town, which is about a half an hour drive, 25 minutes drive perhaps, up to the observatory. And you would only observe very often for about 2 to 3 hours, an hour setting up. So you would be there to about 5 or 6 in the morning. Then you would get back in your car, drive home. And but there was an intimacy. You would be in the control room with the telescope outside you, with the lights on the telescope. It's a radio telescope, so there were lights. And it was you, the telescope operator, all of whom were dear friends, still are dear friends. When we call up to the observatory, it's always a 20-minute chat with the operator, finding how they and their families and their dogs are. And it really was like losing a member of the family. We got called something like 20 minutes after the collapse of the telescope on the 1st of December by a friend of ours who's now an astronomer at the telescope. And he just arrived at the front gate just after the collapse. And he called us up, and we were all just completely gobsmacked. There's no other word. Tapasi and I have not been able to look at the video of the actual collapse.
We just can't see it. We haven't.
People have said, "You haven't seen it," and we say, "No."
Can't.
If a relative of yours had just been knocked down in a car accident, would you be able to look at the video of the accident? We can't watch it. Maybe one day, but not yet.
No.
Not yet. It's too close.
And I think many people who work there, the tertiary that was in there, we actually put the nuts on that. We constructed that one because as there were two other reflectors, and the tertiary, the third small reflector, the project was running late and short of money. So
shall I tell the story?
Yeah, you tell the story.
The inside of the dome had a secondary reflector, which did the first part of refocusing the rays from the spherical main mirror. And that filled the whole inside of the dome. It's about 25 meters across. And then there was a smaller tertiary reflector, must have been about 8 meters across, I guess. And one day we seemed to be permanently at tea. We were at our tea time.
All good ideas come from tea.
No, this was a phone call. There was a phone call. Somebody picked up the phone, and it was our director in Cornell, up in New York State, asked for me, and I got called to the phone. And the conversation went something like, "Hello, Don Campbell here." "Oh, hello, Don, Chris here." "Yes, Chris, I wanted to ask you, if I was to request you and the astronomy department to assemble the pieces of the tertiary reflector, do you think you could do it?" I said, "Well, Don, that's a bit of a surprise. What's the reason?" He said, "Well, we're really running out of funds on the upgrade. And to be honest, we can't really employ people to assemble the tertiary. Do you think the astronomy department could do it?" I said, "Yeah, I'm sure we could, Don. I'll just go back and put it to the astronomy group here. We've got them all at tea along with the astronomers and the radar group." So I put the phone down, walked back to the tea table, said, "Hey, astronomy group, we've got you all here. Just got Don Campbell on the phone. He'd like to know, are we all prepared to assemble the tertiary reflector to go into the dome?" And everybody at the astronomy group looked at me and said, "Yeah, we can do that." So it'll mean working in the sun for a few days.
Turning some screws, joining up plates and turn screws.
Yeah, sure. Yeah, we'll do that.
Given instruction.
So I went back and said, "Yeah, Don, they're all gung-ho. We'll do it." Put the phone down, and I went back and we finished our tea. And everybody went back to their offices afterwards. And one of our young astronomers, Susan, came up to me afterwards and said, "You know, Chris, that was a wonderful practical joke, saying you were going to ask the astronomers to assemble the tertiary. I think they actually believed you." And I said, "Susan, that was not a practical joke. We're going to assemble the tertiary." And she looked absolutely flabbergasted. "Really?" "Yes, really." And so the week afterwards, there we were out beside the rim road, assembling the tertiary. And for the next 24 years, there it was inside the dome, doing its job. And by amazing coincidence, the platform is now sitting on the rim road, slap bang where we assembled the tertiary. It landed right on top of where we did the job. But I think that was a wonderful case of, astronomers really aren't engineers, but if you call them into the moment
Manual
and say,
job,
will you
they
do
can
it?
do
The
it.
answer is yes, we will.
Yeah. Like that, it was part of all of our lives. Like that's why we were there. And
It's true of all observatories.
yeah.
I have a colleague here who's just retired, Frank Gigo, and he was through Greenbank, right through the building of the Greenbank 100-meter telescope here. And he and another colleague wrote the history of Greenbank from the earliest days up until the GVT, the Greenbank telescope, was observing. And the title of the book was But It Was Fun. And that's my feeling, that we chose the right profession. It was fun all the way through.
Not the last bit.
Not the last bit. The last bit was, and that's why it was so unutterably sad.
Absolutely.
Because it was fun. Well,
I mean, the thing is, none of us ever expected that this will collapse because, the whole structure has been there since 1957. And anytime they did an inspection, the report or the impression was those cables are going to last for 100 years. Like all the bridges, the big bridges are standing today. They were built in FDR's time, maybe, and they're still there. Nobody expected that. So it was not in our mind that it could all fall.
Yeah, if you were to do it again today, I suspect you would try and put in a more modern way of monitoring the state of those cables.
Oh, yeah.
The first cable that fell was the shock, because that didn't break. There was some as yet unexplained failure in the socket. It
just came out of a socket. It was in a box. The cable went there and just slipped out of that. Cable didn't break. And
that was not one of the cables from the early days. That was a cable that went in place in the 1990s upgrade. Okay. That should not have happened. And that's still unexplained. But what is happening now is a big surge of interest in doing something to make sure that there will be an Arecibo 2.0, as it's being called. Whether it will be exactly the same as the old telescope, whether it will be an improved version of the old telescope, whether it will be something totally different, or whether, tragically, it will be a memory, only time will tell.
I think there's enough pressure for them to not close the doors right away. So right away, that's not happening. And there's huge protest. Everybody's, people of Puerto Rico really loves the place. And, it's like an iconic symbol for them. And every school student go through the observatory. There's been tremendous outpouring of support. Like one of the star reporter there, who is actually a meteorologist, and she's a PhD meteorologist, Ada Monzon. I don't know if you've seen her name or not. She just reported, she's been reporting on that. She has a huge following. And she said on that day, whole Puerto Rico cried with you. So, and that is true. That's no exception. So no exaggeration. So that's it has enormous public support. So we'll see what happens.
Yeah.
Sure. Let me start again. So I'm Roberto. I am a fourth-year mechanical engineering student at the University of Puerto Rico in Mayagüez, and there I am also the Vice President of Students for the Exploration and Development of Space at the UPRM, UPRM. But now I am also leading this effort to save the Arecibo Observatory with our movement that started just a few weeks ago when the NSF decided to demolish the Arecibo Observatory. And now our focus in this movement has changed to seek the reconstruction and the improvement of the Arecibo Observatory. Right, so my earliest memory of being at the Arecibo Observatory comes when I was in like 3rd grade, and that was back in 2009. And it happened to coincide with the visit of Puerto Rico's first astronaut, Joseph Acaba. He came to the Arecibo Observatory, and my dad took me there. And it was like a double win for me. I got to see the Arecibo Observatory for the first time, and I got to see one of my heroes, Joseph Acaba, because I still wanted to become an astronaut. That's my life goal. But then flash forward to 2015, and I'm in the 10th grade, and I started in this program called the Arecibo Observatory Space Academy, which was a Saturday research program for highly qualified high school students in Puerto Rico, where we got to do science research, science and engineering research. That was my first ever scientific research experience. And in that academy, AOSA, that's how we call it, I became really, really invested in a lot of different fields, such as aerospace engineering and planetary science. I've always wanted to become an astronaut, but I didn't really know in what category or what field I would specialize in. And being in the world's premier facility for astro research, I realized I had an innate passion for planetary sciences and asteroids. So I said, I'm going to become a planetary scientist, but I really want to become an aerospace engineer as well. So I said, well, I can combine two. And I figured out that I can become a multidisciplinary individual and become an aerospace engineer that understands the science of the places that we're going to, and conduct the human exploration and robotic exploration of these planetary bodies. And that's when it clicked to me that having those multiple backgrounds to help me also become an astronaut. So I continued in that academy doing research with space debris. I developed a simple method that became an alternative to the problem of space debris. And I completed the research. I graduated the program, which is a semester-long program, from January to May. That was my cohort. But then I wanted to do more. I wanted to continue learning. So I applied again to the Arecibo Observatory Space Academy, and I was selected. But that second time, they selected me as a teaching assistant. So I had to help the mentors, teach the other students, but I also got to do research. And luckily for me, after a couple of months of doing the theoretical research, studying, I was granted the opportunity to participate in a planetary radar observation campaign of 2 potentially hazardous asteroids. Those are the ones that can represent the risks to the Earth. And that for me was the best thing ever, because even though I didn't even touch a button, I got to see how the astronomers use the Arecibo Observatory. I got to be in the room where it happened. I got to be there and see the data come down. And when I saw the images from the asteroids that we observed, I was really happy and amazed by that. I remember that moment. I remember even the feeling of the room, and that's when I realized that I really want to become a planetary scientist. And that was in the 12th grade. That was my last research experience. So I was there from my 10th grade to my final days in high school, and that was about 2.5 years of experience at the Arecibo Observatory, of going there almost every Saturday, spending there more than 8 to 12 hours every Saturday. And I got to, do a lot of work, but I also got to do a lot of friendships and relationships that are still happening, with my mentors, with my friends. Some of them are like my family right now. So it had a lot of impact on myself. And without the Arecibo Observatory Space Academy, I wouldn't be who I am right now. The experiences that I got there, the knowledge that I got there allowed me to become a better leader, a better person, and a better student. I've had experiences with NASA and internships and in programs, and it wouldn't have been possible, at least not as fast as it did, if I didn't go to the Arecibo Observatory Space Academy. And that's why I will say that I owe it all to them. And it's also one of the reasons why I'm doing this Arecibo Observatory movement, so that we can help other students also have a future that is enabled by the capabilities and the programs that exist at the Arecibo Observatory. We deeply care about the Arecibo Observatory, and we want that to remain as the premier center for education in space here in Puerto Rico and in the world. And we hope that within a few years we get it back. In this academy, every cohort, every group of students, we were like 30 students per semester, sometimes a little bit more, about 40. And in my role as a teaching assistant, I was kind of their mentor, and I helped them throughout their research, but I also was their friend. And they were in my same age group. Some of them were a year younger than me. Some of them were a year older than me. So we got along too well. We had the same interests. We like space. We like science. So we were there together in the Arecibo Observatory. We look out of the window and we saw the platform hanging. So that was a really cool experience for us. It was also a place for us to learn how to become professional, how to balance what is your friendships and the professional aspect, because you have to remain serious at times. You also have to find time to have fun. So that was something that I certainly didn't know before. And when I got there, I got to work in that environment. And I also got to work with these mentors, planetary scientists who had a lot of experience, and they showed me the ways throughout, to go in and work at a scientific facility, all the manners that you have to have, the respect, and also they teach all of us how to think like a scientist, how to reason correctly, how to implement the scientific method. And aside from that, from the academics, all the classes that we had at the Arecibo Observatory Space Academy, as I said, they were composed of about 30 students, and every group was like a family. We spent a lot of time together on Saturdays, but we worked throughout the week. We remain in contact through video chat, through WhatsApp, different places on the internet. And now, a lot of us, I think most of us are in university, and a lot of us go to the same university, the University of Puerto Rico in Mayagüez. So we hang out together, we work together in our projects here. In fact, the people that graduated from the academy, they created Set2PRM. And when they created Set2PRM, they created this place for university students to come together to work on space-related things. I'm right now the vice president of the association. The president of Set2PRM was also part of AOSA. I was his TA when he was a student. So, I work with them, and I've known, I would say, about 40 to 50% of my current colleagues. I've known them for 5 or more years. So we have a lot of experience together, and we know each other, we know how we work, and we know what works and what doesn't. So it has certainly helped us achieve a lot of things, with my friends, and that came from the Arecibo Observatory Space Academy. I've gone on to win NASA competitions and other achievements, and it all, it was thanks to AOSA. And let's see what else I can tell you. It was great also because in AOSA, we're people from different municipalities in Puerto Rico, different towns. So I come from Mayagüez, that's on the west side, but I had people that came from the east side of Puerto Rico, the other side of the island, and from the north, to the south, the center. So we have a lot of different perspectives, and we came from different high schools. So different high schools in the public and the private system. So that was also a mix of cultures for us to see what it's like outside of your high school in your town. The Arecibo Observatory was the only place in Puerto Rico where active space science was conducted, or is conducted. It was for us a jewel of science and a beacon of hope. It was the place to go and learn about space. That was our icon. For a lot of us, knowing that we had the facility in our backyard, quote unquote backyard, it was a sense of pride for us, because nobody else in the world had it. And if somebody has something similar to that, it wasn't as unique as ours. And it was also one of the favorite tourism spots in Puerto Rico. About 100,000 people went to the observatory each year, so that was a lot. And about half of them were students. So it was something that people frequently visited, and people went there and enjoyed the exhibitions, of course, the site of the Arecibo Radio telescope, the platform that collapsed. And they also went to the observation nights that they hosted almost each 2 months. So it was the place for us to become inspired. And I know hundreds of students that were impacted positively when they went to the Arecibo Observatory, people that were inspired to pursue careers in science, engineering, technology, and mathematics, STEM. And thanks to the Arecibo Observatory, now we have a lot of professionals working in those fields, and some of them have worked on NASA projects, and while others are still in Puerto Rico working to develop and benefit the country. So the benefits of the Arecibo Observatory, just by being there and being such an icon, are just, super great. I think that it depends on who you ask, but I think that being popularized in so many movies, such as the James Bond movie, Contact, and so many documentaries, science documentaries, I think people were amazed by the design of such an observatory, because you don't see a hanging observatory like that. You don't see 3 towers with cables with a platform in the middle and a big dish. That's really a different thing. And I would think that if this was like a normal observatory, perhaps it wouldn't have been as famous as it was, because we have a lot of dishes with antennas, and that's it. We've had an array of that, and people are used to that. And you can confuse that with communications antenna. But with Arecibo, it was such a different design, and people were amazed by, first, how it was constructed, because when you imagine people in the 1960s constructing such a big thing, you become interested in it. And when you see the pictures, you're amazed. And also, people are interested in knowing how the structure remain up all the time until it collapses, because how are you gonna hold a 900-ton platform with cables? People that are not engineers are not going to understand, on first sight. So I think a mix of that, and also the popularity that scientists and moviegoers have had with these movies, have really contributed to the world-class status that Arecibo Observatory had. Oh, it's been quite a few interesting months since August, when the first cable broke. When I heard the news, I was surprised, because I had seen it so many times, but I never imagined that I would become it will become unstable by losing that cable, and then even more unstable when time passed. And I became really worried about it. And I said, well, it's just a cable, and it was an auxiliary cable at the time. And I thought, well, they can fix it. At least it's not a main cable. So, and they were working on it, and we would hope that they were working on it with sufficient speed to get it done faster, but they didn't, because bureaucracy. And then flash forward a few months to November 2020, and we see the news that a main cable broke. And that's when I said, oh man, this thing is gonna fall. Like, I realized that the other cables, I've taken engineering classes, and I understand now that the cables have a limit, that each material will break at a certain point. And I said, well, those cables were not designed to export that way. It's just a matter of time before they collapse and get fractured. And even though I was hopeful that they would come in, maybe the military or somebody will take over and stabilize the structure, I knew that with every second that passed, the Arecibo Observatory or radio telescope, the platform, was nearing its end. I knew it. But, I just had to remain hopeful. And when on December 1st, before that, I knew that it was gonna fall. And the day after Thanksgiving, I went with some friends of the Save the Arecibo movement, and we went to the observatory, and we saw it from a distance for the final time. And I remember just looking at it and saying, "Oh, this might be the final time that I see you up. It's final time that I see you there." And even though I was far away, I saw it, and it looked such as if nothing happened. I couldn't see the dish from where I was, but to me, it just looked normal. And just 4 days after that, we got the news that it would collapse. I was up at 7:55 in the morning, and a friend of mine, Raleigh Friedman, she lives next to the observatory. She sent me a message and she said, Wilbert, I heard a noise, a big noise. And I said, oh no. And then she says, Wilbert, it's down. And I didn't realize, I was like, oh my God. And for me, it felt like somebody in my family had died. When you get the news of somebody died and you say, nah, that you must be joking, you must be kidding. I was like that. Even though that it was a real possibility, I didn't believe it. I said, I'm gonna fix it. And then she sends me the picture of the platform. And the only thing that I see are the 3 towers. I don't see the observatory in the middle. I don't see the Gordon Dome or the azimuth arm. I don't see anything. And I was so blinded by the emotions that I didn't notice what was happening at the moment. So I just got into my car, grabbed my clothes, got into my car, and I drove to Arecibo. And I got there like in an hour. And for me, see at the distance, when you go to the Arecibo Observatory, there's a road with, that takes you from different places, and you can see the platform. You can see the platform by the road. And when I saw the towers at the distance and no cables, no platform in the middle, it was shocking. Being there or going there for 2.5 years of your life, almost every Saturday, you become used to seeing a certain thing. And when you don't see it anymore, it's certainly something shocking. And I was really, lost for words. And the closer that I got to the Arecibo Observatory, I realized that this was happening, that it broke and that it collapsed. But I was also filled with adrenaline. I was, texting people, tweeting people, and I was like live tweeting all this situation on Twitter so people could see what happened. And when I got to the place where I could get closer to, I just sat in silence and just look at it because that's all I could do. And it's been almost a week after the collapse, and I'm still here, thinking about it. And when I see pictures and videos of the last day that I saw it before the collapse, I just become too emotional to do anything else. Our movement, Save the Arecibo Observatory, which was intended to save it before collapsing, now has a different meaning. We want to reconstruct the Arecibo Observatory. And I started the movement with some friends just a few minutes after the news came out on November 19 of the decommissioning. We wanted to stop that from happening. And in about 2 days, about 140 people, now we're about 168 people. Most of them students have had experiences with the observatory. We came together to do something about the issue. Now we work in tandem with the scientific community to develop solutions that are feasible, to develop a new plan for the observatory. The scientists and the engineers are taking charge of the actual design of the new observatory and the proposal that they're putting out. But us as students, we took the initiative to inform the public about the importance of the observatory, why it is still relevant, why it is still unique, and why we need to have it. Aside from all the scientific advancements that it can bring, it is also a source for tourism, for economic development. And it's also one of the reasons why a lot of people live where they live in Barrio Esperanza, which is a neighborhood next to the observatory. So we're taking the responsibility to inform the world why it matters to us as students, why it matters to the scientists, the engineers, the community as a whole, because, and Puerto Rico and the world, because Arecibo was the first line of defense against asteroids. It was unique in its capability to track and monitor these asteroids. There are certainly other places in the world that can do that, but not with the same resolution, not with the same capabilities that we've had. And people often compare it to China's FAST telescope. But the truth is that China's telescope is bigger in diameter. It's about 500 meters in diameter. But the area that they use to study sometimes is much more smaller than the one that we have at Arecibo. So it's not comparable. Also, I say to people and explain to them, so imagine Arecibo has a mouth or eyes. It has eyes and it can also hear things. And in China, the only thing you have is a big ear. You can only receive stuff. You cannot transmit radar. That's a major difference. We have the big ear, and we also this mouth or the eyes or a flashlight, so that we can shine the light on asteroids, shine the light on the planets, and see how are they behaving, how close they are to the Earth, how fast are they in relation to the Earth. So we have capabilities that nobody else has. China doesn't have, Goldstone in California doesn't have, and losing it will weaken or science and also our security as a world. And I want people to understand that it wasn't just a telescope that you could see out of this, out of a scope. We didn't do that. We have a lot of different capabilities that nobody has, and people should be aware that the Arecibo Observatory is that important for us. I think I've said enough, and I summarized everything, but I just want to reinforce the fact that the Arecibo Observatory is important to us Puerto Ricans, to the United States people, but also to the people of the world. People get inspired, as you said, by watching this in movies, and we want them to come to Puerto Rico in the near future when everything, becomes normal again, and enjoy the science facility that we have here and learn about the universe. And we want that to happen, but we need their help. We need their help to reveal the Arecibo Observatory. We created a petition to the White House to consider this, and are working with scientists diligently to get this done, because we cannot lose the observatory forever. We need to rebuild it within the 2-3 years from now, so that we can continue doing science. It is certainly true that we have enough data to do a lot of science, but there are things that are constantly happening. There are asteroids that are coming near Earth. There are observations that must be done. Conjunctions with planet, Mars is there, Mercury is there, and things are gonna happen in the next few years that if we've had that Arecibo active, we could learn a lot from. But fortunately we don't, and we need to prioritize its reconstruction so that we can get back on track with science and engineering. And I will also say that you can follow us on social media, Twitter, Facebook, Instagram, Save the AO or Save the Arecibo Observatory, so you can stay up to date, because we are in Puerto Rico and we are just a few minutes away from the Arecibo Observatory, so we can get you up to speed and get you the latest updates on what's happening in the situation, so that if you're interested in helping us out, you're gonna be able to do that by following us there.
Yeah, I mean, it was a real gut punch. I mean, I still get verklempt when I think about the fact that it is gone now, because it was such a major part of my career and my life too. Both of these things. So it's like grieving the loss of something that I had over again, essentially. Right. So I was inspired by Contact to want to work at Arecibo. So as a senior in undergraduate, I got an opportunity to do an internship there. And I was just like over the moon. I couldn't believe I was going to be at this place where all the magic happened. And it was a fantastic experience. I got introduced to planetary radar, which was not a thing that I knew existed prior to going there. And coming from an astronomy background, I was just awed that you could manipulate the signal that you were sending out into space like an experiment, as opposed to just passively waiting for the universe to sort of send you its information. So I love that, and seeing the asteroids really inspired me. And then when I went on to graduate school, I was able to use radar to study the surface of Titan, which is Saturn's largest moon. And I've been using radar ever since. So without that experience, I probably wouldn't be where I am today in my career. And then on a personal note, it was a really huge year for me, and all the other students who were there, because as I mentioned in my email, we did lose 2 other students that summer on June 21st, 2003. So losing Arecibo, like I said, feels like losing them all over again. It's part of their memory. There's a plaque there to commemorate them. I don't know what's going to happen to all that. But yeah, I mean, I would give anything to get those two young men back. But it certainly was my first brush with death too, as a 22-year-old, and sort of kickstarted my life in a way that I perhaps was not, taking advantage of all the opportunities I had been up to that point. And so I wanted to squeeze every ounce of life out of it. And we started, all of us, all the other students started doing that summer. We all became certified scuba divers, went on these incredible trips all around Puerto Rico. We were just really keen to make the most out of our lives. And Puerto Rico was a great place to have those new adventures and those new experiences. So for sure, that was, Arecibo is and was a huge part of my life. And I just, to have it gone is just heartbreaking, doesn't give it justice, I think. I really wish we could rebuild it. It was such a treasure for American science and science around the world. There's no other place like it in the world. And I keep thinking of, it'd be great to do this experiment, and then stopping myself. Oh, we can't, it's not there anymore. All these observations we had planned, are not go forward unless we rebuild it, or rebuild something capable of doing the same sort of science that it is. So I was involved in the 2003 research experience for undergraduates, or REU, at Arecibo. So there were a large group of students living there. We lived at the site over the summer. And, over the weekends, we would do little activities. And there was one day in particular, June 21st, 2003, where we sort of split into two groups. I was with a group that went to go see sort of an archaeological site nearby. But there were 3 other students who decided to go for a hike behind the telescope. There's a river there. It's in karst terrain, so there's lots of caves and waterfalls and so forth. And we came back to the observatory that night, and something just felt wrong, and I felt this bad feeling in the pit of my stomach. And we eventually heard from one of the students who went on the hike that she didn't know where the other two young men were. They had been in the river. She looked away for a moment, and when she turned back, they were gone. And so we spent that whole night just not even knowing what happened to them. We got, hope, like they heard some people, oh, maybe they're still alive. I mean, at that point, we didn't know what had happened. They could have just gotten lost. But eventually it became clear that they had fallen off the top of a waterfall and gotten sucked into a cave underneath. So they both drowned. Which was awful. And so there was this huge group of students who was just grieving, right? And nobody quite knew what to do with us. We flew to Miami for one of the students' funerals. But yeah, it was really hard, obviously, to focus on work. So we kind of all just banded together and tried to support each other through the experience of losing these people, and understanding that it could have been us so easily, and so angry that they were gone, and wishing to go back in time and change it. Thinking back all the steps you took that day, like, oh, what if somebody else had gone to the hike to the river? Would it have been different? Or what if they'd stayed back and gone to the archaeological site with us? All those what ifs, right? Just plague you. Yeah, so I certainly took the, carpe diem approach. I realized that life was short, and so you should take advantage of every moment you have, because that's a real gift that you're given. is this ability to experience life. So yeah, so after, you know, a lot of grieving, I think a lot of the students, we all came together to try to make each other live the best lives that we could. So it was great to have the support of the other students in sort of seizing the day and trying new things and making the most out of our time in such a wonderful place. So it was both, you know, the worst thing that had happened to me at the time and also the best thing that had happened to me at the time. And I took that, you know, joie de vivre forward into my life as I went to grad school and continued on and yes, so for many years after that, I was really seizing the day. I went skydiving, I went backpacking through the wilderness. I, you know, traveled as much as I could. I just wanted to take advantage of the time I had on Earth. Yeah, so when I was there, it was just an introduction to planetary radar. And as I said, I was just so enthralled by the fact that you could transmit a signal out into space. It would bounce off some feature in space, an asteroid, a planet, and then get returned to Earth, and you could analyze the signal. And it would tell you how big the asteroid was, how rough it was, how fast it was spinning, what shape it was. All this information that you could only get with planetary radar. And there really is no facility like Arecibo on Earth. The sensitivity it had, you know, the transmission power. You could see out to Saturn and get pictures of Saturn and its moons. That's how powerful this radar was. In my own research, I started taking advantage of the data to look at other planets in our solar system. So it's one of the few ways that you can get radar information about Mercury or Mars. We have no spacecraft there with a radar capable of taking images of either of those planets. So that's our only information about those planets comes from Arecibo. In terms of the moon, we have amazing maps of the moon in radar that I've used in my research. And in addition, one of the things I know they've been working on recently is looking for changes on Venus since the Magellan spacecraft visited there in the early 90s. So, you know, looking for new lava flows that could have formed in the past 30 years was one of the things that Arecibo could do. And actually, we had observing scheduled for October after the initial cable snapped to observe Mars, which was something I've been really curious about. They have these amazing lava flows there that are super rough and we don't know why. And so I was hoping to use this new data to understand that better. But because of the, you know, the telescope was crippled at the time, we weren't able to take those images. Now we won't be able to take those images. In addition, I'm a co-investigator on NASA's Lunar Reconnaissance Orbiter on the Mini-RF instrument. And so in 2010, that instrument actually lost its transmitter. It failed. So we weren't able to take images of the moon anymore. But our team came up with a fantastic idea, which was to use Arecibo as our transmitter. So we literally sent a radio wave to the moon, bounced off the moon, and was received by the spacecraft, which was orbiting the moon, which is, you know, an incredible feat of engineering. and we were able to take more images of the moon using our instrument, using Arecibo as a transmitter. And so now that it's gone, we no longer have any data at that particular wavelength. It's just, there is no other transmitter on Earth that could do that. So that was a huge loss for us as a team. So we're fortunate that Mini-RF actually had 2 wavelengths. And so we can use the Goldstone radars in California. They're smaller, they're not as powerful, but we can use that to get, it's called X-band data. This is like 3 centimeter data versus 12 centimeter data, which is what Arecibo transmitted. So thankfully, we're not totally up the creek. We can get some data It depends on how close you are to the object. So for the moon, we could get, 100-meter resolution. And I think some asteroids, they were able to get quite fine scale, like metered, tens of meters scale. When you're talking about Mercury or Mars, they're a little bit further away. Now we're talking about the kilometer scale. So, but if it's the only data you have, I mean, that's still really important. I mean, Arecibo was able to characterize the water ice deposits on Mercury. So people sometimes say that the Messenger spacecraft found water on Mercury, but really it was Arecibo that gave us that information 30 years ago, and Messenger just confirmed it essentially. Yeah, like I said, it was like a punch to the gut. I mean, I watched that video of it collapsing, and I couldn't focus the rest of the day. It just like drained me of my motivation. It was like grieving, the loss of my friends all over again. Yeah, it was really hard to focus after that all happened.
So do you
and
think
I still get emotional just thinking about it, really. Right, I know there's a petition which I signed that is encouraging the White House to rebuild the observatory. So we really have to wait to see what the Biden-Harris team wants to do. It is such an important icon for Puerto Rico. It brings in money for their economy. So many visitors would come. It inspired so many students to study space science. One of my master's students is Puerto Rican, and she graduated last year and is now pursuing a career in planetary science. It obviously, inspired her, and there's countless others like her that were inspired to study STEM because of Arecibo. But it's such a tricky political situation. Nobody really knows what to do with Puerto Rico and the US Congress, and they don't have any prominent politicians to support them as other states might, because they don't have voting power in Congress. So I don't know what's going to happen to it. I would strongly support, any effort to rebuild the telescope, though. And when you think of it in comparison to other budget items like buying a new tank or, a new weapon of mass destruction, this is just like a drop in the bucket. So it really comes down to priorities, right? Well, FAST is a great instrument, but it has no planetary radar capabilities. And for me, that was, what made Arecibo so unique and so powerful, was this ability to transmit and receive signals from the solar system. And FAST simply can't do that. Not only that, there is different wavelengths involved, and when you're looking at radar images, or radio images, it's extremely important, the wavelength. You learn different information depending on what part of the electromagnetic spectrum you're in. So without that planetary radar capability, I just don't think there's really any comparison between the two. That's a good question. I don't know. It's sort of like, it was a magical place. It seemed like impossible that it even existed. It was so big, and it was just hidden away in the jungle, right, of Puerto Rico. It was just so unexpected to like come out this windy road up from Arecibo to get to this telescope, and then out of nowhere, you look down and it was this humongous, bowl in the middle of the jungle. It was an impossible place, and yet it existed, and there was just some magic to that, I think. Well, I guess so. Yeah, I talked to the New York Times a couple of days ago, and they caught me when I was very angry. And they made we were talking about the science, and then they made some sort of like comment like, oh, well, this was inevitable, and because they were going to decommission it. But that was only after 2 cables had snapped, right? And I feel like, yeah, they might have been doing their best to keep up the maintenance. I don't know the details there, but if a telescope collapses unexpectedly, something went wrong along the way, and somebody could have noticed that and fixed that. And I don't know what went wrong, but I don't think it was inevitable, like this New York Times reporter was implying. I think something could have been done to save it before we got to this position. And that makes me frustrated and angry and sad. And so I wish it didn't come to this, essentially.
The Arecibo telescope was a monument to science, an incredible icon of engineering, human ingenuity, and, I think, design, nestled deep in the Puerto Rican jungle. It was originally conceived in the late 1950s to study the ionosphere, but it's left its mark everywhere, from astronomy to the search for alien life to the cinema. You might remember it as the enormous dish in 1995 Bond film GoldenEye. The dish itself is a giant segment of a sphere, over 300 metres across, and it's sunk into a natural karst depression, a type of geology that gives rise to soaring towers and huge basins in the landscape. That means that engineers could search for a hole that was as close to spherical as possible, making it possible to install the dish with the minimum of earthworks. The incredible structure took 3 years to build, and when you understand its complexity, you can see why. It's an upside-down dome made of 38,778 perforated aluminium panels, a bit like giant cheese graters. It doesn't matter to the radio waves that Arecibo observes that they're full of holes, because the waves are so big they effectively don't see them. But it makes the structure significantly lighter, and it means that wind and rain can pass harmlessly through it, rather than weighing it down and buffeting it in storms. Because the dish is built into this depression, and perhaps more importantly because it's absolutely enormous, the dish itself can't move to look at different parts of the sky. So Arecibo instead moves its receiver, suspended 150 metres above the dish by cables from 3 towers, collecting radio waves reflected at different angles from different parts of the dish. Because the dish is spherical, it effectively looks the same from every direction, allowing the telescope to scan a significant fraction of the sky, even though it looks like it's just pointing straight up. It's hard to imagine just how big this thing is. A giant bowl 305 metres in diameter. It was the largest single-dish radio telescope in the world for over half a century, until it was succeeded by the 500-metre aperture spherical radio telescope. No prizes for guessing how big that one is, which is located in southern China, and builds on Arecibo's incredible legacy. I'm just really sad I'll never get to see Arecibo. I was lucky enough to visit its successor, FAST, for a documentary, and it's the most awe-inspiring structure I've ever seen. It's so huge it's impossible to really convey in words, a genuine engineering marvel. I always hoped I'd be able to visit Arecibo, the original classic version, but alas, this beautiful, literal giant of science is no more.